You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Server clustering is the practice of linking multiple physical or virtual servers into a single logical group that delivers a shared service. These servers, known as nodes, work together to increase the availability, performance, and fault tolerance of applications. When properly configured, a cluster allows one node to take over if another fails. The Server Plus certification includes clustering principles and techniques for roles such as file sharing, print management, and database hosting. High availability is a core goal of server clustering. Mission-critical systems cannot afford to be taken offline by hardware failures or maintenance downtime. Clustering allows for automatic failover when a node becomes unresponsive and, in some designs, for active workload balancing. In enterprise environments, clusters are a fundamental design element that ensures continuity of service across multiple layers of infrastructure. There are several types of clustering, each suited to different use cases. In an active-active cluster, all nodes process workloads simultaneously, sharing the total load. This increases performance and fault tolerance. In an active-passive cluster, only one node is active at a time while others stand by in readiness. If the primary node fails, a standby node takes over. Server Plus includes understanding the differences between these designs and when each is appropriate. Clusters rely on heartbeat protocols to monitor node availability. A heartbeat is a simple signal sent between nodes to confirm that systems are responsive. If a node fails to respond, the cluster initiates a failover process. Protocols used for heartbeat detection include CoreSync and Pacemaker in Linux environments, and Microsoft Failover clustering in Windows. Heartbeat intervals and thresholds must be tuned to balance responsiveness and stability. Cluster storage configurations vary and impact both performance and complexity. Shared storage allows multiple nodes to access the same disk volume, usually over a storage area network. Replicated storage maintains separate copies of data on each node and keeps them synchronized. Shared storage is simpler but can be a single point of failure. Replicated storage increases resilience but requires more careful design and monitoring. The choice depends on workload and infrastructure. Failover occurs when a node stops functioning or becomes unreachable. The cluster detects the failure and moves resources to another node. Policies determine how this process unfolds, including whether the failed node is rebooted, the service is restarted elsewhere, or administrators are notified. Server Plus includes the ability to configure failover behavior and test that it works correctly before going into production. Cluster quorum is a mechanism that prevents split-brain scenarios. In these cases, two parts of a cluster may each believe they are the authoritative node. Quorum uses voting to determine which node or group of nodes continues running the service. The number of votes required depends on the total number of nodes and the quorum configuration. This planning ensures the cluster behaves predictably during partial failures or network splits. In active-active clusters, load balancing helps distribute resource usage. Load may be distributed based on central processing unit consumption, memory allocation, or client connection count. Load balancers, either hardware or software-based, direct traffic to the least busy node. Balancing ensures that no single server becomes a bottleneck. Proper load distribution is essential for maximizing performance and minimizing user impact during node transitions. Some applications are designed to be cluster-aware. These include Microsoft SQL Server, distributed file system, and other enterprise tools. They can respond to cluster events, failover correctly, and distribute workloads. Other applications require special scripts or configurations to run in a clustered environment. Compatibility testing must be completed before deploying applications in production clusters. Server Plus includes identifying and preparing cluster-compatible services. Cluster health must be monitored continuously. Tools check node responsiveness, service status, storage usage, and network paths. Alerts notify administrators of failover events, degraded performance, or pending resource exhaustion. Logs from the cluster manager should be reviewed after every failover to confirm root cause and validate behavior. Monitoring ensures that small issues do not evolve into full service disruptions. Cluster management interfaces simplify setup and maintenance. In Windows, administrators use failovercluster.msc or PowerShell. On Linux, common tools include PCs and CRM Shell. Some platforms also offer web-based interfaces. These tools allow configuration of node roles, failover conditions, heartbeat settings, and application assignments. Role-based access should be enforced so that only authorized personnel can modify cluster configurations or trigger failovers. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Cluster configuration files store critical settings, including node names, roles, failover policies, and scripts. These files must be backed up regularly and tracked through version control. Unauthorized changes can disrupt failover behavior or cause data inconsistency. Permissions must be configured to restrict access to configuration files, ensuring that only trusted administrators can modify them. Keeping these files secure and up to date supports stability and audit readiness. Failover behavior should be tested under controlled conditions. Testing includes both planned transitions, such as during maintenance, and unplanned events like simulated node crashes. Logs and monitoring dashboards must be reviewed to confirm that failover occurred correctly and within acceptable timeframes. Lessons learned from testing should be documented, and recovery procedures should be updated. Testing ensures that real-world failures do not result in unexpected downtime. Clustered systems must be updated carefully to avoid disrupting availability. The preferred method is a rolling update, where one node is updated and rebooted at a time while others remain online. Passive nodes are patched first. After patching, the cluster is failed over to the updated node, and the next node is serviced. Compatibility between applications and updates must be validated. The cluster must remain functional throughout the process. Disaster recovery planning in clustered environments requires additional considerations. Secondary clusters or failover sites must be established in a separate data center or region. Storage replication between sites must be validated regularly. Quorum and role assignments must be considered in the context of geographic separation. Recovery procedures must include cluster reassembly, data validation, and service restoration steps. These plans must be tested like any other disaster recovery process. Cluster licensing models can vary based on vendor and deployment type. Some software is licensed per physical or virtual node, while others count active instances only. Clustering features may be included in standard editions or may require enterprise licenses. Administrators must understand the licensing impact of scaling clusters, enabling features, or activating failover. Budgeting for clustering includes both hardware redundancy and ongoing support costs. Securing cluster communication is vital to prevent tampering or interception. Heartbeat messages and management commands must be encrypted or transmitted over isolated management networks. Firewalls, virtual private networks, and certificate-based authentication are common safeguards. Clusters must be configured to reject unauthorized nodes and detect intrusion attempts. Hardening cluster communication reduces the risk of compromise or service instability. Cluster documentation must be maintained to reflect the current state of the environment. This includes maps of nodes, virtual addresses, storage configurations, application assignments, and network interfaces. All failovers, patch events, configuration changes, and administrator logins should be recorded. Documentation supports troubleshooting, change control, and audit requirements. It also ensures continuity when teams or roles change. Clustering is a foundational technology for high availability in modern infrastructure. It ensures that services remain online even when individual servers fail. Designing a successful cluster requires careful planning, compatible applications, secure communication, and consistent monitoring. With proper failover policies and disaster recovery planning, clustering provides a reliable platform for mission-critical systems. In the next episode, we will begin Domain 3 by exploring security and disaster recovery principles essential to resilient server management. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.